And we are live. Hi, Kurt. How are you?
Hello, how are you?
Happy Wednesday.
Yes, it is.
Thank you so much for joining today. So what are you gonna tell us? What are you gonna talk about today, please?
Well, today's topic, since we're out of the box, it's something that's out of my comfort level, out of my skill
Okay.
set, out of all those things. Today I'm talking about insulation, our
Okay.
value of closed cell insulation. So there's different types of insulation. I'll get into the R values and how they're calculated, but I just want to start out saying this is not my industry. So please, take this information and use it wisely. Um, I, I I took some of my knowledge from doing volume calculations for things like ground, and I've done some walls after the collapse of Ground Zero at the World Trade Center. I created a model of the slurry wall, so calculating volume there.
Cool.
So things like that, we laid it on our back and did contouring. But in this case, with 3D models now, I can actually just model it right at its face and start to look at some values there.
So how did you end up calculating like the insulation? Is it value? Was it this a project at home that you had to do for some
Yes.
reason, or
Yeah,
okay?
so my wife and I were rebuilding an abandoned house. So
Okay, cool.
part of the downside was the exterior walls were 4-inch studs, and
Mm-hmm.
building code requires 6-inch studs for exterior walls. So because I didn't have that thickness, and I'm up in Northeast United States, it's quite cold up here. In fact, we got a lot of snow and ice out there now.
Okay.
Insulation was very important to me. So I did my research on insulation, and we decided to go with closed cell spray foam insulation within a 4-inch cavity. That would give me what I'm looking for. And really, if everybody knows about lumber, 4 inches is really 3.5 inches when it comes to wood. Even though I do have a
Mm-hmm.
couple 2x4s in here that are real 2x4s, they measure 2 inches by 4 inches, but they're rare, and that's the old lumber.
Okay. So how did you use then? How did you go from creating the 3D model, which I think you did using just your mobile phone? Am I
Yes.
correct?
Yeah,
Okay.
so some of the weirdest part was because they were doing spray foam insulation, I couldn't get into the house
Okay.
because of the chemicals and stuff like that.
Yeah.
They're in full suits. Plus, I lived over 5 hours away. So,
Not very convenient.
yeah, and plus having a 1-year-old baby at the time and trying to drive that distance, that 5-hour trip took really like 7.
Getting tougher
So I
and
could only
tougher.
come on the weekends. And what was
Mm-hmm.
happening was I would come on the weekend and walk through the house, and I would find areas that I had an issue with. So then they
Okay.
would send the guys back. They would address those issues. I would come back the next weekend, see
Mm-hmm.
more issues. And I hit a point of frustration,
Yeah.
and I got tired of what I felt was doing their job for them.
Yeah.
And because I like to, not to say take shortcuts, but I like to use my mind to think about something first and basically be smart about my process, and that's what I did here.
Okay.
I'll share my screen with you.
Yes, please do so. There we go. Yeah.
Okay, so what we're seeing here, this is a spray foam wall. You can see the writing, where
Mm-hmm.
they're putting the outlet boxes. We see the box here. Now, it's a little
So
hard.
sorry, Kurt. So
Yeah,
what we're seeing now is the 3D model.
yes.
And tell me, before getting into the story, I'm sorry to interrupt, tell me a
No,
bit
please.
more about the data capture. Like, how did you capture the images for that 3D model?
Yeah, so this was 60 images. I used
Mm-hmm.
my phone, and basically within a couple minutes, because like I said, most of the time when I'd run in the house, it was run in real quick, look at things, and then leave, because I had
Mm-hmm.
my wife and baby out in the car, and we couldn't be really in the house. So
Yeah.
I'd wear a mask to go in and take my measurements. But it comes down to time. If
Okay.
I'm sitting there, and really how this worked out was I was taking measurements. I had this metal poker. I actually have it somewhere here. This metal poker that I put electrical tape 3 inches up on it. So this way I could punch it through the foam till it hit the board behind it, and then I could see if I hit that mark, which means I have 3 inches of foam. But I'll get into the R values then.
Okay.
But what we're seeing here, you can see there's some areas where it comes right to the surface and it needed to be cut back. But then there's areas behind it that are kind of voids. we also see, I mean, there's areas around different areas where just visually I can see on the side of the 2x4 if we're within that half an inch. So we see that there were some areas that I brought up of concern where they went back and sprayed, but just spraying up the side of the wood still didn't give it the depth. So then I was putting a straight edge across these two 2x4s and taking my measurement in to see.
How did can I ask, how did the company react when you send like such a detailed information on you, like this is not a good job?
Well, so number one, if anybody knows about closed cell insulation, it's extremely expensive. And when I looked at getting R13 value and R21, and I needed R21 to meet the code, and I was a stickler for things. And then what happened was I would come in and just get within 10 feet of the front door of walking in, and I would find 40, 50 problem areas. So I'd bring the guy in, meet him there, and we'd walk through, and I'd say, look, I found 40 areas just in this 10 feet. And this is a very large project, so I need somebody to go around and examine everything. I don't want to do it. I don't want to come in on the weekends and have to back check somebody's work, bring their boss in to see that I found these problems. I want their boss to do that. So because I wasn't going to go around poking, I had some issues that I'm like, look, if I'm poking through this and putting these holes, I'm now creating all these holes in this sealed insulation, you know, and per bay, I was putting 40, 50 holes in the thing. And then they're telling me, oh, take caulk and fill in the holes and stuff. And I was like, I'm not doing that. I'm not. So what I'm going to do is create a 3D model of this wall, and I'm going to break it down and start calculating my R values. And I'm going to show you how I did that. But let's say that their jaw hit the floor and I said, look, I could do this for every wall. And they said, no, you proved your point.
And did they think, or did they get back to you on how did you do these? Like
no, they didn't want to know. They were, I would use the words embarrassed. And I'll get into some of the details about my frustration with it.
Okay, fair enough. Okay, cool.
So I threw together just a quick little PowerPoint, nothing beautiful. But why did I do this? Well, let's take a look, and we see here when I have a cross section of it, I'm moving through, and what we're seeing is that red plane there is really what an R21 insulation should look like. It should be at that level. So technically, I would expect it to be right above that red where I don't see any red. So like the left bay there's enough in there. Oh, actually, I don't think I put insulation in that bay or did this R value check. But you can see that I had some measurements there. I have the measurements of the studs. Those two studs together are 3 inches. And then you see here that I actually showed the depth of how much we were lacking underneath that R21 value.
So the red indicates where the insulation should have reached, right?
It should have been there.
Yeah, okay. And the white is the actual insulation that they put,
Yep.
Okay.
And something like this, I can, within a couple minutes, take my phone, create the 3D model of it, and then I brought it in a ContextCapture editor and just...
I'm still really interested in the fact that you spent like a couple of minutes taking 60 pictures. I'm not good at data capture. Like I tried a couple of times.
I've seen what you did. It's very good.
No, it's not.
I saw your
Thank
dog.
you for that.
If anybody that can model a dog that, you know, is just sitting there, that's pretty impressive.
Maybe I should publish it, but like it's just it doesn't have the nose, like it's just. But yeah, like I think we should do another session on data capture, maybe for best practices and things to consider. Like don't do moving objects like a dog.
Yeah. So when it comes down to speed, maybe we can have a follow up out of the box session talking about using video to create these models.
Oh yeah, that'd be great. Actually, you mentioned a couple of
that.
times. Yeah, you mentioned a couple of times that video is maybe like a safer way for people that are just getting started with ContextCapture.
Yep.
Yeah. Okay.
So let's get into a little deeper of why I did this. So I had limited time. As I said, I couldn't get in, and I lived 5 hours away. And with a newborn, it pretty much was come in, look at the problems, and leave. And I couldn't go through the whole house. Sometimes I was just holding my breath to come through just to see what was done. But I found numerous holes or deficiencies in it, which then, poking these holes through it, and then they're telling me to use caulk. I found 50 problems within 2 feet. For me to sit there and poke and make all these measurements, that was too much work. So they actually asked me to mark out things, and I was using blue tape. And I wish I had some of the pictures. As I mentioned at an earlier out of the box session we did, I lost a hard drive, and a lot of this stuff was on there. So I just found some photos that I had backed up somewhere and kind of recreated this for this. But the process was very simple. But I found voids. So we can see here, right behind, there's voids, obvious ones that you could see here. When I can see that much of the studs, and like here, I mean, I'm seeing half the stud.
Yeah.
I should only see half an inch. Here is almost half the stud. Again, we see this all over, even areas that had little extra boards. And you can see this little clump here. That's actually after I had them come out that I marked this area. So that's where my frustration was. I was marking up these areas, and they would come back and just patch a little thing and not even patch it the proper way. So then I'd have to bring the manager back in. And then it got to the point where they just started overspraying. And then I had to go through, and we see here, I couldn't put gypsum board up on this with the way that this was sticking out. You can also, this is a very dark picture, so I apologize, but along the top here, you can see this is the ceiling. There's multiple areas where the foam was sticking down. So like I said, they asked me to mark it. And this is one of the, what I would say, best walls, because some of the other walls look like they were nearly all blue with the amount of marks that I had to put on here. The marks were a lot more when they were short. This picture is actually me marking where it was sticking out too far, where I had to put a straight edge across it, and it was rocking because the insulation was sticking out too far. So I put blue tape to mark those areas. But even here, marking with blue tape, this was ridiculous. There's no reason that I should be walking around this project putting blue strips of tape everywhere. So I said, well, how can I represent my discrepancies without just putting blue tape everywhere? So let's get into deeper what our values are. And like I said, I'm dealing with a 2x4 wall, which is closed spray foam. So the properties, and our value per inch of spray foam is 6.5. So if we look at the thickness of the spray foam that they would need, they can put 3 inches in. That leaves a thickness of a 1/2 inch of airspace. Oh, this is another thing, that when they would come through, one guy would mark it, and he would stick a wire through, and he had a 3-inch spackle blade. And when he would take his thumb out, I'd watch him roll his thumb to hold it up and say, oh, I'm within the 3 inches. And I had my poker that was exactly measured 3 inches, and I'd put it in and see he's 1/2 inch shy. And I'd say, so your method where you're rolling your finger is really not accurate, where at least you should have a poker that's marked at 3 inches that you could go around and check it that way.
Yeah.
Then he started saying, well, we have a 1/2 inch of tolerance. Now, I'm all about tolerance. I've done aerial mapping, and I know national mapping standards in the United States is I have to be 90% accurate, or I have to be accurate to half a contour interval on 90% of my project. So when he says 1/2 inch tolerance, I would expect that he has 10% that he would be allowed to be less than that, that 1/2 inch that we're looking for. So then as I started investigating this more, I realized I had to go back and train him or educate him in our values, because what was happening was we have 6.5 to 3 inches. There is a 1/2 inch of airspace. When somebody told him that they had a 1/2 inch tolerance, that's what they're referring to. It has to be at least 3 inches, but it can't be more than 3.5, because then we couldn't put the gypsum board up. So that R value gives you 19.5 for those 3 inches. And then we have the R value of the airspace, which is a little less than 1. So together with the 3 inches of foam and the airspace, I'm getting 20.4. Now, I even told them technically his contract saying that they're giving us R21, and I'm saying there's no physical way for them to give me the R21 unless they encroached on that 1/2 inch of airspace, which I would have been fine with, but they didn't like cutting back. It was too much work, so they were trying to play with that. Well, let's say how I did this. So I created 2 planes. So what I did was, since I don't have a scan of the wall before the foam was in, which I actually do, but that's another story. Um, I have the face of it. So I created 4 points around the wall. I created a plane on that. I put a shape on that plane, and I moved one back 1/2 inch, which would be the R21, and I moved one back 2.5 inches or 2 inches to give me the R13. So it would be 2 inches from the back, really 1.5 inches back from the front. The basically, like I said, I put it on the face of the bay and then just moved it backwards there. So kind of in a negative measurement. So the R13 has a setback of 1.5 inches, 2 inches of foam, which is R60 6.5, which would give us the R13 if we were only doing an R13. Now, the reason why I'm mentioning this R13 was because there was times I'm saying, look, you're charging me for 21, but you're still not even giving me an R13 value. So as we see here, this is the R21. So that red area, really, I shouldn't see any red. And if I do, I want to see a cross section where it's very, very close. And I'd say, all right, it's a little shy, but it's acceptable.
Yeah.
When I'm talking 1 inch shy, we're now going to R13 and we're talking twice the price. Now, you know, you're messing with money, and that's where, if you're charging me for something, give me what I'm paying for. So when I look through this, we see here is anything where you're seeing that purple color, that means it's not even up to the level of an R13. So of course you see most of it is, you know, the foam color. But everywhere I see those little spots of the purple, that means that we're not even at an R21, we're not at an R13. And like I said, in those cross sections, we see that I cut a section right next to where the light switch was, and that was 1 inch. So I looked at this picture here, and this is what I brought up on my iPad to the manager. And I said, look, here's the wall. And I stood right in front of the wall. And I said, we can see right here that there's blue area. So you see this blue area, and then around where the studs are, but then I see red area right next to it. So I actually went through and I showed them all the blue area is there. The cyan coming up really would be just something that's over the R21, but less than the wall. The dark blue are stuff that they had to cut back right to the wall. The green would be the R21, what is legit for R21, and then the R13, and then we have the red. So we see this red spot right here, right next to the light switch. And we also see another one right here. See how there's like 3 little divots, and then down in this lower right, we have some too. If I look at the mesh model, we can see this area down here. That's obvious that it's shy. You know, just because they sprayed foam up the side of the wall doesn't mean that it's that thick right at this point here. So you can see that it was lacking. As I mentioned, also up by the light switch, we can see here, and if I turn off the texture, we can see how it divots in here. So what I did was I held up, you know, the iPad that showed the symbol, and I said, look, we can see here, let's eyeball it and say we're a couple inches over. Now, when I was standing at the wall, you could see these obvious spots. So I showed, you know, this red area. I just walked up to the wall, roughly down a little lower than the light switch and right along the seam of the board. I could see that mark. I went through, put my poker in there, and showed the guy again. I said, so now instead of me having to poke around all these spots in this wall and then have to go patch all these poke spots, I just took the pictures of it right here quickly. Thematically, I could see each level or each layer that we're looking at.
Yeah, I mean, this is amazing. Like, obviously you took the, you know, opportunity to say, hey, I'm going to be smart here. I'm going to show you and educate you on how to properly, you know, you're not giving me the service that I'm paying for. But I'm like, I can't stop thinking, why is this company not using this 3D modeling to actually inspect their work and make sure that the inspectors don't. Of course, because like we had a live a few weeks back with Greg and a company, a roof inspecting company. Like, they've transformed their company in 1 year because they've digitalized the inspection process. And for these guys, how many times they went back to your place, communication,
16.
like, it's
16
unbelievable.
times. And
Oh my
to tell you
gosh.
the truth, after the 16th time, I gave up. Oh, I don't even get into. I had a heat gun that I was going through areas that got covered up that I was putting a heat gun on. I actually ripped open parts of the floor, found voids that they missed. And then I had 300 sheets of gypsum board out in the yard waiting to be put up. And so they were holding back my contractors from putting up the sheetrock. And it got to a point where I said, you know what, I can't keep going back and forth with you. And I also have pictures. I bought these small cans of foam, and I went through and did hundreds of spots still before we put the boards up. And then when it comes to the ceiling's supposed to be, I have 6-inch boards for the ceiling, and they're supposed to be 5 inches of insulation. I went through the same process here with the insulation, which was like an R39 or something. Don't quote me on that. But I just lost all my frustration on the walls. That the ceilings I kind of gave up on. It was hard to just get work out. But I agree with you. If you're a company that's doing spray foam insulation like this, you could use this to train your employees. Because I watched these guys come back 16 times, and then I have to get their boss back each time to look at their work, where I felt he should have just been checking their work. And this is a case where if somebody goes in and sprays this, if they go through with their phone, take these pictures, now when I'm the client and I call the owner or the boss, they can go right to their model and see.
Like any company that is doing, any work like installation, roof inspection, anything that has to do with a physical asset, and you have to send people to the field, like having the 3D model, you do the job, you took some pictures, create a 3D model, and that can be utilized not only to communicate to the end customer, which is like, hey, Kurt, here you go, the final results and whatever. We'll have to go back because there is some areas that, I don't know, we didn't do a good job that day, or we had these issues and so forth. But the money that you save, and also the advantage and the added value is unbelievable.
It was just my phone and our software. And when I poked in the area and said, look, I can see this is 2 inches shy, and I poked and it was 2 inches. I said, this area, and I said, look, I could do this all day. I could, it's the weekend. I'll spend my weekend taking pictures around and calculating. I mean, the calculation part's the easy part. Really, the time-consuming part, which was rare, like little, but was getting it on plane. And the truth is, I did this 2 years ago where we didn't have QR codes. Today, I would put 4 QR codes up on the corners, take my phone, take my pictures, have it automatically add the constraints, the plane constraints, my scale constraints, all that for me.
So it would be even faster.
This could be done very quickly, and it's efficient. I even have 3D models of the walls before the foam was in there, so that I could see exactly where wires and pipes are. Because once you cover this, you can't see where the wires are, and you have your little depth finder or whatever, stud finder. Well, when you're dealing with closed cell insulation, everything is a solid mass. So having the 3D model showing me where all the wires are and the plumbing and all that stuff is extremely helpful for me. It's a digital twin. And I have it through every aspect, from pre-construction, during construction. Right now, if I need to know, because as you see, not every wall here is 16 on center. Some of these walls, are kind of mixed in between. So I rely on this model to know exactly where my studs are, where my pipes are, so that I don't damage anything.
Of course. Yeah. I think this is a very interesting use case. Thank you so much for sharing this.
You're very welcome. Do we have any questions?
I couldn't see any messages coming through, but my internet is acting a bit funny. So, but I couldn't see any. Let me just go back to the main screen here. I don't think so. So are we going to show the video, processing video capture next time? Video footage, sorry.
Yes. So next time what I'm thinking is showing even faster ways to capture data using video. And it's something that I normally shy away from, but let me tell you, we've been very successful with it. I've been doing it for years, and sometimes you don't have a choice. I mean, there are times where video is your only option. For example, in
Okay.
this house, I could show you, I had a floor ripped open that my wife laughed at me because I said, oh, I had to grab something. She was in the car and I ran inside and I came right back out. And later that night, we were staying at my mother-in-law's house and I'm working and doing something. My wife comes over. She goes, is that what you did when you ran inside? I said, yeah. So I ran inside. I was only probably 20 seconds. I shot
Yeah.
video, recorded, ran around the room, shot whole video of the open floor so that I had a whole 3D model so that now when they built the floor back, I know exactly what's under the floor and where we are. And because of
That's very
time and
cool.
my wife, wanted to leave, and it was something that in 30 seconds I could shoot video and still create a 3D model. But we'll get into
Yeah.
all the cool things that I could do with video. I use it for
Okay.
training, and sometimes you can even create models when you're not even there. It's quite
Okay.
amazing.
Wow. Okay. So let's do that in 2 weeks from today then.
Yes, that sounds great.
Okay, cool. Thank you so much then.
You're very welcome. It was great to see you again.
You too. Thank you, Kurt. Thank you everyone for joining. Bye. Bye.